Hello everyone, I welcome you all to my YouTube channel. So this is the last video of the polynomial series, class 10 maths. This is the part 5. If you haven't watched my previous videos, you can go and watch them. So let's start today's video. The first question is, if alpha, beta and gamma are the zeros of this polynomial kx cube minus 5x plus 9, and it is given that alpha cube plus beta cube plus gamma cube is 27, then we need to find the value of this k. So we will be using this identity in our question. A plus b plus c cube is equal to a cube plus b cube plus c cube plus 3 times a plus b into b plus c into c plus a. So if you don't know this identity, I have also provided the proof below. But for the exam perspective, you can directly remember this identity. So the proof is as follows. You must be knowing this identity. A plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. Now what I am doing here is that I am writing a as a but capital B as b plus c. So this is one term and this is another term. So when I apply this identity, I replace a by a and b by capital B by b plus c in this whole expression. Just substituting a by a and b by capital B plus c everywhere. You get this. Now this is again a plus b whole cube. So I've expanded it. I've expanded it as a cube plus b cube plus c cube plus 3bc into b plus c. This is the expansion of this part, and here I have written as it is. After this, I have taken 3 times b plus c common in these two terms. So I'm left with bc here and a into a plus b plus c here. So I have now multiplied these two terms and got this. Rest part is the same. Now I have reordered the term. I have written AC before right here and just reorder the terms. So now I've taken C common here. I'm left with A plus B, and I've taken A common here. I'm left with A plus B. So after this, I have taken a plus b common, a plus c is left. So I got this expression a cube plus b cube plus c cube 3 times b plus c into a plus c into a plus b, and I have reordered the terms because in multiplication ordering does not matter. So now let's come back to the original question. After we know that identity, so from sum of roots and product of roots, we will be knowing that a is in this case is k and b is 0 because x square term is 0, c is minus 5 and d is 9. So sum of roots will be 0 because there is no x square term, and product will be minus 9 upon k, right, minus d upon a from the. So alpha cube plus beta cube plus gamma cube will be equal to alpha cube plus beta cube plus gamma cube plus 3 times alpha plus beta into beta plus gamma into gamma plus alpha. So this expression value is 27 we are given in the question, and this value is 0 from here, and alpha plus beta from here can be written as minus gamma. I have written it. Beta plus gamma can be written as minus alpha. I have written it. And gamma plus alpha from here, gamma plus alpha can be written as minus beta. So I have substituted here. Now 3 times minus will be minus only. It will become 3 into alpha beta gamma. So 27 is equal to 3 into alpha beta gamma. Alpha beta gamma becomes 27 by 3, which is 9. And value of alpha beta gamma is minus 9 by k. So minus 9 by k is equal to 9. So k will be equal to minus 1. So this was from your HOTS. So let's move to the next question. So how many polynomials are there having 4 and minus 2 as zeros? So this is from your RS Agarwal. Answer is more than 3. These are the options 1, 2, 3 or more than 3. So why more than 3? Because sum is 2 and product is minus 8. So we can take any integral multiple of this expression that can be the required polynomial whose roots are these two, alpha equal to 4 and beta equal to minus 2. You take k equal to 1, 2, 3 or anything. So there are infinite many polynomials, so infinite means more than 3. So let's move to the next question. The zeros of the polynomial x squared plus 88x plus 125 are both positive, both negative, one positive, one negative, both equal. So this is again from your RS. Suppose alpha and beta are the zeros. So alpha plus beta will be minus 88 upon 1 and alpha into beta will be 125. So if you have watched my previous videos, you must be knowing that if alpha and beta are greater than 0, then there are two cases arises, that both alpha and beta are greater than 0 or both alpha and beta are less than 0. Then only their product will be greater than 0. Because if suppose alpha is 2 and beta is 3, then the product will be greater than 0. And suppose if alpha is minus 2 and beta is minus 3, then also the product will be greater than 0. So if alpha and alpha is greater than 0 and beta is also greater than 0, if we consider this case, then alpha plus beta is also greater than 0, because sum of two positive numbers will be also a positive number. But we are given that sum is a negative number, so only this case can happen, that both alpha is less than 0 and beta is less than 0, then only their sum will be less than 0. So this means that both alpha and beta are negative. Both negative is the answer, right? And now another question, just exactly the same as this question. Now they have replaced the coefficients by k. If this polynomial is given and given k is greater than 0, then we have to predict the roots. This question is also again from your RS. So we'll proceed similarly. If suppose alpha and beta are the roots, so alpha plus beta is equal to minus k and alpha into beta is given as k. Now we are given that k is greater than 0. Again two cases arises, that alpha is greater than 0 and beta is greater than 0, or alpha is less than 0 and beta is less than 0. This case will again fail because here the sum will be positive, but from here we know that sum is negative. Why? Because k is greater than 0, so minus k will be less than 0, so alpha plus beta will be less than 0. So only this case can happen and the answer will be both negative, right? Let's move to the next question. If one of the zeros of the quadratic polynomial k minus 1 into x squared plus kx plus 1 is minus 4, then the value of k is. So one of the zeros is, so x equal to minus 4 is one of the zeros. So f of minus 4 will be 0. So we calculate f of minus 4 by replacing x by minus 4 in this polynomial. We get k minus 1 into minus 4 square plus k times minus 4 plus 1 equal to 0. So k minus 1 into 16 minus 4k plus 1 equal to 0. So 16k minus 16 on multiplying, we get 16k minus 16 minus 4k plus 1. So 16k minus 4k is 12k and minus 16 plus 1 is minus 15. Minus 15 is taken on the other side. K becomes 15 by 12, that is 5 by 4. This is the answer. This question was from your RS. So let's move to the next question. If minus 2 and 3 are the zeros of this polynomial fx equal to x squared plus a plus 1x plus b, then we need to find the value of a and b. This is very similar to the above question. We need to proceed in the similar way. X equal to minus 2 is the 0, so f of minus 2 will be 0. Similarly, x equal to 3 is 0, so f of 3 will be 0. This is from the concept of roots. You can watch in my previous videos. In the theory part, I have covered this. So f of minus 2 will be calculated by replacing x by minus 2. So I have replaced x by minus 2. I get minus 2 square as 4 into this multiplication minus 2a minus 2 plus b is equal to 0. So I get this equation 1. Now I calculate f of 3. So f of 3 is calculated by replacing x by 3 in this polynomial. It becomes 3 square is 9 plus 3a plus 3 plus b equal to 0. So 3a plus b becomes minus 12. So I've got two equations in two variables, linear equation in two variables. So you can easily solve them if you know your chapter number 3 of your NCERT book, linear equation in two variable. So from here I write the value as b is equal to minus 12 minus 3a. I have taken my 3a on the other side, it will become minus 3a. So I put this value of b in this equation number 1. So I get minus 2a plus b value is minus 12 minus 3a will be equal to minus 2. I have done nothing, just replace the value of b from here and put it in here. So minus 3a, minus 2a and minus 3a will become minus 5a. 12 will go to the other side. 12 minus 2 is 10. So a becomes 10 divided by minus 5. So a is equal to minus 2. And I replace a is equal to minus 2 here and get b is equal to minus 12 into minus 3 multiplied by minus 2. So first we'll multiply, it will become plus 6. So minus 12 plus 6 will be b is equal to minus 6. So I get a is equal to minus 2 and b is equal to minus 6. So this is the required answer. So by this I come to an end of this video, and I have covered all the important questions from this polynomials chapter. So after this I will be starting a new chapter. If you want me to start with any specific chapter, you can comment down in the comment section. So please like, share and subscribe to my channel to get all the recent updates about all the videos that I make. Okay, I'll see you in the next video. Till then, goodbye.